Hello everyone. Today we will try to understand the fundamental concept behind deep learning. Deep learning is a field of machine learning which is used to solve some very complex problems like face recognition, language translation, etc. Let us see how deep learning differs from traditional machine learning. First, it finds complex patterns in the data, that is, it can solve complex problems. Second, it requires lots and lots of data compared to traditional machine learning. Third, it is computationally expensive. So it requires CPU and often GPU to crunch to the data. And finally, it requires a lot of parameters to be tuned. So it has a lot of constraints and parameters which needs to be tuned. Let us look at some of the basic building blocks of deep learning before we actually understand the whole deep learning network. One of the building block is a neuron. A neuron is loosely based on a biological neuron which is present in a brain. Given an input X, it generates an output Y based on an activation function. An activation function could be just thought of a mathematical function which, for example here, returns a value of 1 if the value of X is more than 0.5. That is, if it is above a certain threshold, it generates a 1, otherwise it generates 0. So it could be any activation function. We have a lot of activation functions which we will see in future videos. So basically it will activate a neuron based on an input, hence the name. Now let us deep dive into neuron a bit more. Let us say we have multiple inputs to a neuron. As shown here, we have inputs x1 and x2. And each neuron, each input line has a weight. x1 is associated with a weight w1, x2 is associated with a weight w2. Now we first compute the sum of the products. For example, we find x1 multiplied by w1 and x2 multiplied by w2 and we sum it up. Then we add a bias value to it. A bias value is generally generally 1. And then finally we apply the activation function on the sum. To summarize, the whole equation would look like activation function applied on the sum of the products and the sum of the bias. So this is the basic working of a neuron, and if we understand this, next slide we will try to understand how to build higher order of network using this basic building block. Now let's try to find out what happens when we interconnect neurons. In this case, we have 3 neurons and the output of N1 and N2 forms as the input to the activation to the neuron N3. So this is how we interconnect neurons. Now let's try to increase the number of neurons and let's look at a network which has many more neurons, and here we can see 3 different layers. The first layer is the input layer. The second and third form the hidden layers, and the last layer is known as the output layer. So this is how a typical neural network is built. So an input layer, an output layer, and one or more hidden layers in between. And the neurons in one layer are connected to the neurons to the next layer. So this is how a network is built. Now let's try to increase the number of hidden layers much more. Here we can see we still have the input layer, we have the output layer, but we have many hidden layers. This is what we call a deep neural network. So, and this is how a deep neural network is formed. I think now you got an idea what is a deep network. Now a question comes to our mind: what does a deep learning model learn? So initially the weights will be set to 0 or small random values. As part of training, the weights will get updated and the network learns the correct weights based on the training data. So here the actual learning is in the weights, and when the network has completed the training, the weights represent the actual learnings. Now, how does a deep learning network learn? There are two phases. The first is called the forward path, wherein the data flows from the input layer to the output layer in the forward direction. The second phase is known as the backward pass, whereas in wherein the data flows in the backward direction, in the reverse direction. As a result of these two phases, the weights get updated. Finally, what is a deep learning model? What does a deep learning model comprise of? A deep learning model could be represented by the number of layers which we saw, the number of neurons in each layer. The number of neurons can vary, so we can tune it. So that also is part of the model, and the values of the weights and the values of the bias. So these form a deep learning model. And remember, when we talked about machine learning, a machine learning model is just a mathematical function represented by an equation. Any machine learning model is represented underlying by a function. Even in the case of deep learning, the deep learning model is represented by a function, a nonlinear equation. However, the equation may not be humanly readable. It could be really complex. It learns the patterns in the data and could be represented by a very complex equation which may not be comprehensible by human mind. But end of the day, it's again represented by a mathematical function which it learns and is represented by the layers, the network, the layers, the neurons and the weights. So that's it in this video. I hope you liked it. Thank you for watching.